Just a minute. Hi. This instructional video is about dilation. Dilation. So the previous videos we talked about was dilation, and it dealt with enlargement, where the scale factor was bigger than 1. So when a scale factor is bigger than 1 or bigger than 1, if it's a scale factor of 1, that's a size in itself, so it doesn't change. That's the original. But if it's greater than 1, it enlarged. But now we have a scale factor that's between 0 and 1, fractional that is. So it's going to be smaller than the original. So let's plot these points. There's 3 coordinates here, -7 and 8. So here we go. So we have a triangle. Now we're going to dilate this at a scale factor of 1/2. So whatever this original was, we're going to make it half of it, fraction of it, using the origin as a center. So once again, graphically, what you would do is you would measure the distance from one vertex to the origin and only take half of that, which may be like somewhere over here. I don't know. I'm just taking a wild guess. But that's graphically. So what we want to do is we want to find the actual coordinate that's half the distance. We're going to do it analytically. So we're going to take each of those coordinates for the value x and y, and we're going to take half of that. So for example, here's the coordinate A at -7 and 8. So we take the x value -7, and we're going to take half of that. Therefore, it becomes -7/2. That's going to be what? -3.5 maybe? So the x is -3, 1, 2, 3 and a half. Right there. And the y value is going to be 8, so we're going to take half of that. So half of 8 is 4. So the new coordinate, the A prime, is going to be at -7/2 and +4. That's the new coordinate. So -7/2 is like saying 3.5 and 2, 4. This will be the new location right there. That's the A prime at the coordinate -7/2 and 4. So how about the B? Well, the B was given at 12 and 10. And so we're going to take half of the x value, 12. And half of 12 is, of course, 6. And half of 10, that's an easy one too. It's just 5. So the new coordinate, which is half the distance from the origin, is going to be at 6 and 5. So 2, 4, 6 and 2, 4, 8. It's right where I thought it was going to be, at B prime, which will now be at 6 and 5 coordinate. And the C will be half from the origin, so maybe around here, I think. I don't know. So analytically, meaning we check it. So let's do the C at the coordinate 10 and -5. So half of 10? That's a 5. Half of -5? Yeah, it'll be 5/2 negative, or -2.5. So let's plot this one. So 2, 4, 6. So the 5's over here, right there. And we're going to go down 3.5. So 1, 2, 3.5. See that right there? I think. No, that's not 3.5. That's 2.5. Be careful. Okay? That's 2.5. Woo! I almost made a mistake. So 2.5. There it is. Whew. And that's a C prime at 5 and -5/2, or -2.5. So let's plot those 3 points, and it will look something like this. Right there. And right there. Okay? And see that? It's half the distance of the original from the origin and half the perimeter, whatever it's supposed to be. All right? All right then. Now that you saw how that was done, graphically and analytically, using numerics, why don't you try this one, where you dilate the given polygon of this coordinates by a scale factor of 2/3. See, 1/2 will be too easy. You try the 2/3. Go ahead, try it.